Hello to everybody. Welcome to the video lecture on superposition theorem. Superposition theorem is one of the simplest and easiest network theorem, and it's very well applicable for the analysis of circuit consists of multiple independent sources. Before going to the actual statement of superposition theorem, let me give you the basic idea or principle behind the superposition theorem. Consider the circuits shown in figure. So we have a single circuit in left hand side and two circuits in the right hand side. So as per the statement of superposition theorem, in simple words, we can say the analysis of circuit in the left hand side is equal to analysis of circuits in the right hand side. So let's go into detail and understand what we are doing in the left hand side and right hand side. So in the left hand side we have two voltage source V1 and V2 and bunch of resistors R1, R2 and R3. The voltage across each of the resistors or the current flowing through the resistors R1, R2, R3 is due to the effect of voltage source V1 and V2. So this is what present in the left hand side. The right hand side, we have two circuits. Circuit 1 consists of V1 source is on and V2 is removed or V2 is off. Right? Circuit 2 consists of V1 is off and V2 is on. So as per the statement of superposition theorem, the voltage or current in any of the elements due to voltage source V1 and V2 is equal to the voltage or current due to voltage source V1 plus the voltage or current due to voltage source V2. Right? Suppose if you want to calculate the current I flowing through the resistor R2, of course, you can calculate the current I flowing through the resistor R2 using a number of circuit analysis techniques such as KVL or KCL or mesh analysis or nodal analysis. But how do you calculate the current I using superposition theorem? So to calculate the current I using superposition theorem, first you have to activate one source. For example, you activate the source V1 and deactivate the source V2. Now by using any of the circuit analysis technique, you can calculate the current flowing through the resistor R2 and assume the value of the current as I1. Then you activate the source V2 and deactivate the source V1. Again, do the same analysis technique and find out the current flowing through the resistor R2 and assume the value of the current as I2. Then as per superposition theorem, the net current or the effective current due to both source V1 and V2 is equal to current due to V1, that is I1, plus current due to V2, that is I2. So as per superposition theorem, the net current due to multiple sources is equal to the algebraic sum of the currents due to each independent sources. Right? So with that a basic idea, let's move to the actual statement of superposition theorem. So superposition theorem states that the voltage across or current through an element in a linear circuit is the algebraic sum of the voltages across or current through that element due to each independent source acting alone. Let's discuss step-by-step procedure to apply superposition theorem. Step 1. Select one of the independent sources. Set all other independent sources to 0. So step 1 says that you have to activate one independent source and deactivate all other independent sources. How do you deactivate the sources? How do you practically deactivate the sources? So this is equivalent to setting up the value of the source. The value supplied by the source is equal to 0. If it is a voltage source, set V is equal to 0. If it is a current source, set I is equal to 0. But before that, you should understand what is the electrical equivalent of V is equal to 0 and I is equal to 0. Let's remember our previous lecture slide of open circuit and short circuit. A short circuit is a circuit element with the resistance approaching 0. So for short circuit, R is equal to 0. Since R is equal to 0, the voltage across a short circuit is equal to 0. So the electrical equivalent of V is equal to 0 is a short circuit, right? So look at the another side, that is open circuit. So for an open circuit, the resistance is equal to infinity. Since the resistance is equal to infinity, the current flowing through the open circuit is equal to 0. That is, I is equal to 0. So the electrical equivalent of I is equal to 0 is an open circuit. So to fix V is equal to 0, you have to create a short circuit, and to fix I is equal to 0, you have to create an open circuit. So voltage source needs to be short circuited for deactivation, and current source needs to be open circuited for deactivation. So let's go back to the step-by-step procedure. So first you are activating one of the independent source and deactivating all the independent sources. So this means that your voltage sources are replaced with short circuit. Since your short circuit provides voltage V is equal to 0, and all the current sources are replaced with open circuit, because when you create an open circuit, the I value is equal to 0. So, and another important point is leave dependent sources in the circuit. That is, you should not disturb the dependent sources. Superposition theorem states only the activation and deactivation of independent sources and not on dependent sources. You should not disturb, you should not touch any dependent sources in the circuit. Always all the dependent sources should be in the active state irrespective of your state, irrespective of your analysis, right? That is your step 1. So after activating one independent source, you have to go to step 2, analyze the simplified circuit to find the desired current or voltage. Right? So now you have to start analyzing the circuit with only one independent source and find out the current in the desired element. Right? Step 3 says repeat the step 1 and step 2. Repeat the above steps for each of the independent sources considered. For each of the independent sources in the circuit. Then for each of the step you will be getting a desired response, and finally as per step 4 you have to add all the responses to get the resultant value, right? So these 4 steps you have to follow to calculate or to find out the voltage or current at the required element using superposition theorem. Let's take an example to understand how superposition theorem can be really applied for circuit analysis. Consider the circuit shown in figure. It consists of 6 volt source and 3 ampere 6 volt voltage source and 3 ampere current source, and 2 resistors 8 ohm and 4 ohms. The question is, find out the voltage V across the 4 ohm resistors. So we can do the analysis by normal mesh analysis or nodal analysis, but to find out the value of voltage V using superposition theorem, then we have to follow the 4 steps mentioned in the previous slide. So as per step 1, you have to activate one independent source and deactivate all other sources in the circuit. So let's activate the voltage source 6 volt and deactivate the current source. So deactivating the current source means you are making the current source or current values equal to 0. To fix I values equal to 0, you have to open circuit the current source, right? So now you modify the circuit by removing the current source or by open circuiting the current source. The simplified circuit with only one source is shown in figure. Now you can use a normal circuit analysis techniques to find the voltage V1. So to find the voltage V1, we need the current flowing through the 4 ohm resistor that can be calculated using the mesh analysis. Okay, since we have only one mesh, you can assume the mesh current as I1 and apply KVL to the mesh. You will get the equation as 12 I1 minus 6 is equal to 0. So from this, the current I1 is equal to 0.5 ampere. But our required parameter is voltage, that is voltage across 4 ohm resistors. So let the voltage across 4 ohm resistors due to 6 volt as V1, and V1 is equal to 4 into I1, and which is equal to 2 volt. Now we have calculated the voltage across 4 ohm resistor due to 6 volts. Next we need to calculate the voltage across the 4 ohm resistor due to 3 ampere current source, right? Next you activate the 3 ampere current source and deactivate the voltage source. So voltage source should be deactivated by creating the short circuit and the circuit. So we have created the short circuit here. Now we need to find the current flowing through the 4 ohm resistor. So for that you can apply any of the circuit analysis technique. One simple technique is current division rule. So as per current division rule, if you know the total current entering to the parallel elements, then current through one of the branch can be calculated as, that is current in any one of the element. The current division rule says that IN is equal to the total current I into conductance of the element. Since we are interested on current flowing through the 4 ohm resistor, so the conductance of 4 ohm resistors divide by sum of the conductance in the network. So we have 4 ohm resistors, so 1 by 4 plus 1 by 8. So current flowing through 4 ohm resistor is equal to total current into conductance of the element divided by sum of the conductance of all the elements present in the parallel network, right? So this equation will give you the current flowing through the 4 ohm resistor, which is equal to 2 amperes. So substituting 2 in the voltage equation, we have voltage V2, which is equal to 4 into I3, which is equal to 8 volts. So voltage in the 4 ohm resistor due to 3 ampere source is 8 volts. So what is the net voltage, or what is the consolidated voltage due to both sources? Then we have to add V1 and V2, which is equal to 2 plus 8, and the actual voltage in the 4 ohm resistor due to both sources is equal to 10 volts. I believe you understood the concept behind the superposition theorem. If not, be ready with your questions. I'll be addressing all your questions in the next contact session. Thank you for watching the video. Bye.